In this video I'm going to just run through a few of the Stiochiometry II calculations. I'm going to first go through the one that's on page 451 done out as an example. I just thought it might be useful to see a worked example. Before we even do this, there's two little keywords we need to know about, and they are the limiting reactant and the reactant that's in excess. So the limiting reactant is always going to be the reactant that's in the smallest amount. Once that reactant is used up, then no more product can actually be produced, hence it's limiting. The one that's in excess you have plenty of. So I'll point them out as we go through and it may make more sense. Okay, so first of all we see a student weighed out 10 grams of iron and 10 grams of sulfur. So you have iron and you have sulfur and you have 10 grams of both of them and they're producing iron sulfide. Said after mixing them, she placed them in a boiling tube and heated it to bring about the following reaction. Calculate the maximum amount of iron sulfate that could be formed in this reaction. First of all, we do never work in grams, we always work in moles. So over here, in order to calculate moles, what do? Moles is mass divided by relative molecular mass always. So I'll just write it out here anyway. Moles is mass divided by the relative molecular mass. The relative molecular mass you have to get from the periodic table, and I've done them out here for you. So iron is 56 grams. So moles of iron is the mass given to me, which is 10 grams divided by 56 grams, which will give you a number of moles of 0.18 moles. Okay, I'm going to put that in over here under the iron. For sulfur, the relative molecular mass from the periodic table is 32 grams, so my number of moles is going to be again 10 grams divided by 32, gives you moles of 0.31 moles, and again I'm going to put it in over here. So what this question is essentially saying is 0.18 moles of iron reacts with 0.31 moles of sulfur, how much iron sulfide can it produce? At this stage, I have to identify which one do I have in a limiting amount and which one do I have in excess. So it's very clear from that question, 0.18 is less than 0.31. Hence, this is my limiting reagent. Okay. If I have 0.18 moles of iron, that means that when all of that 0.18 moles of iron is used up to form iron sulfide, my reaction is over. If I've used up all the iron over here, I cannot possibly produce any more iron sulfide, hence that is my limiting factor. Therefore, the only thing I'm actually concerned about from now on is iron to iron sulfide. I have 0.18 moles of iron. The maximum amount of iron sulfide I can therefore produce is 0.1 moles of iron sulfide. So the question asked me calculate the maximum amount of iron sulfide that could be formed in this reaction. It's 0.18 moles of iron sulfide, or of course I'm only ever concerned about mass because the question was given to me in mass. So again, mass is moles multiplied by relative molecular mass. So the number of moles of iron sulfide I have now produced are 0.18. Relative molecular mass from the periodic table of FeS is going to be 56 plus 32, which is 88 grams. So multiply that by 88 and you get 15.84 grams of iron sulfide potentially produced. Okay, so that is just the first question there, example 21.4 on page 451. And I'm now going to just look at example 24.2 as well. Okay, so example 24.2 on page 452 in Chemistry Live, it says ethene can be made from ethanol according to the following equation, and they've given you the equation. C2H5OH goes to ethene C2H4 and water. So that's our experiment that we've looked at before. It says starting with 20 grams of ethanol, you start with 20 grams of ethanol, a student prepared 8 grams of ethene. Sorry, it's not very clear. 8 grams of ethene. Calculate the percentage yield of ethene. So if you're asked to calculate percentage yield, that's going to be the actual amount that you produced divided by the theoretical amount that you could have produced if 100% of the reactant reacted into product, multiplied by 100 just to get a percentage. So this is what we're trying to do. So first of all, you will notice that the numbers are given to me in grams. That's no good. I want them in moles as always. So the first thing I'm going to set about doing is converting everything to moles, which we know is mass divided by relative molecular mass. So first of all, for C2H5OH, which is ethanol, from the periodic table, the relative molecular mass is 46 grams. So please, in your exam questions, write that out. So it's going to be 2 times 12 plus 5 times 1 plus 16 plus 1 equals 46 grams. Okay. If I want to get the number of moles, that's going to be the mass, 20 grams, divided by the relative molecular mass, 46 grams, and we get number of moles as 0.43 moles of ethanol to begin with. Okay. The question asks me calculate the percentage yield of ethene. In order to do that, I need to always calculate the theoretical yield of ethene. So looking at the balanced equation, I have C2H5OH giving me C2H4 and H2O. Ethanol here to ethene are in a 1:1 ratio. So if I'm producing, or if I have 0.43 moles of ethanol reacting, the maximum amount of ethene I could produce is 0.43. So the theoretical yield, or the amount of ethene that I could produce if 100% of my reactant reacted, is in a 1:1 ratio. So 0.43 moles of ethanol in an ideal world will produce 0.43 moles of ethene. So what I'm going to do first of all is just convert that into mass. So of course, mass, using my triangle, okay, mass is equal to moles multiplied by the relative molecular mass of ethene, which is C2H4, okay. The number of moles I could theoretically produce is 0.43, and the relative molecular mass of ethene is 2 times carbon 12 plus 4 times 1 is 28 grams. So 28 by 0.43 would give you 12.04 grams. That would be my theoretical yield of ethene in an ideal world. So the first thing I'm going to do is just highlight that so I remember that it's there. Now, the question actually told me that the amount of ethene produced was only 8 grams. So when a student carried this out in the lab, they were hoping to produce 12.4 grams of ethene. What they actually produced is 8 grams. So we know ourselves loads of little lab errors could have happened in order for that to occur. So many different problems could have resulted in them not producing enough. This is reality of the lab situation. In order to calculate the percentage yield, I want the actual yield produced, which was given to me in the question as 8 grams, divided by the theoretical yield, which I worked out to be 12.04 grams, multiply it by 100, and you get an actual yield to be 65.68%.